Hey, 20-2s. Welcome to this unit that is known as quadratics. We're going to do 2 units of quadratics. The first unit is all about quadratic functions. So here we're really just looking at what do the graphs look like and how do we play around with them. And the second unit is quadratic equations, and we'll do something different in that unit. So we'll be in quadratics for a little bit. So the first question is what the heck is a quadratic? Well, a quadratic is something that in real life, something that follows this shape here or this shape here. There's lots of things in nature that follow this shape. So really anything that I can throw, right? Anything that's up in the air, right? The old expression, what comes up must come down sort of thing. So lots and lots of different things. So anything I can throw, anything I kick, people diving off of diving boards, but they also model different things such as revenue, which is really, really important, and profits, and in terms of some architecture, like sometimes like we build hanging bridges that look like this, so there's all sorts of applications. So that's why we're looking at them. And if you think back to grade 10, we looked at mx plus b. Well, I'm just going to change the m, which meant slope, to a. That was grade 10. Well, in grade 12, you can see below it says a quadratic relation or equation in standard form when it looks like this. Y is equal to ax squared plus bx plus c. So what I want you to notice is we went from degree 1 to degree 2. That's it. Okay? And then when we get to grade 12, guess what? Degree 3. All right, let's play around with these things a little bit. Make sure you've got your graphing calculator with you, please. So there's some really important parts of a quadratic graph that I need you to know. So here is a quadratic graph drawn on a Cartesian plane, and here are the really important things. There's lots of parts to this graph, so pay special attention to this. So part A, the vertex. The vertex is this part right here. So it's the highest, the maximum, or the lowest, the minimum point on the graph. And I want you to think the vertex is 2 things. It's the x-coordinate and the y-coordinate. The equation of the axis of symmetry. Well, a symmetry means that I can essentially fold this graph over top of this dotted line right here, and it'll be symmetrical. So the axis of symmetry is the line that, if you want to think of it, cuts my graph in half. The x-intercepts, well, we know those. They're right there. They're the things that where our graph intersects the x-axis. The y-intercept is right there, so it's where our graph intersects the y-axis. The constant term, this might be a new term for you from last year. It's the term with no variable. So if I'm just going to scroll back up, it's that right there. And by some lucky chance, C and constant. Okay, we'll talk about why that's important shortly. And domain and range, we know, are the possible x's and the possible y's where our graph exists. And we'll practice that because we haven't done that in a while. Okay, so there's the parts to the graph. Let's play around with it, okay? So let's explore a couple of functions. So what I want you to do is grab that graphing calculator of yours, and I want you to plunk in this function. Y is equal to x squared plus 3x minus 4. I'll pull up my calculator here, and I've already got it in. So there we go. And I'm just going to check, make sure my window settings make sense. So I go zoom, and number 6 says standard. So I go standard, and there it is. Okay, so what are the key features of my graph? Well, I want to notice that this graph is going upwards. So this graph has a minimum value. I can see that it's got 2 x-intercepts, and it's also got a y-intercept. So there's lots of important stuff here. Okay, let's break this down. Let's find the minimum first. So I'm going to go, just clear all those steps there. I'm going to go second, trace, and right there it says minimum. And then on the TI calculator, it does this. You see at the bottom of the screen, it says left bound stuff. So I see my cursors blinking. So left bound means just move your cursor to the left of the vertex. Anywhere, it doesn't matter. Hit enter. Then it says right bound. So guess what? I move it to the right, don't I? I'm trying to get there. Boom. And guess, I don't know why they put that in there. Hit enter. And there it is. Okay, so our vertex is at, I'm going to round that, negative 1.5, comma, negative 6.25. Okay, let's write that down. Negative 1.5, negative 6.25. So this was the vertex. And this was a minimum because the graph was opening up. So the vertex is made up of two parts. This value, the y value, is what we would say our minimum is. We would say we have a minimum at negative 6.25. Okay, what is the x? Well, the x is actually the part of the graph that cuts our graph in half. This is our axis of symmetry. So the vertex is made up of two things, the axis of symmetry and the max or the min. And our axis of symmetry is an equation of a line. So we always write it like that. X is equal to whatever that is. So our vertex, again, let's go hot pink here. Our vertex is made up of two things. It's an X and a Y, but I want you to think it's the axis of symmetry and it's your max and your min. So you can usually answer a few questions just by finding that in your calculator. Okay, speaking of calculator, let's go back to that graph for a second. Let's find the intercepts. So to find the intercepts, the easiest one to find is the y-intercept. So your calculator will always give you the y-intercept. So just by hitting the trace button, and I just go along, remember my y-intercept is when it's equal to 0. So there's my y-intercept. To find my x-intercepts, there's a couple of different ways to do it. But what I find is easiest to find the x-intercepts is to go and let y2 equal 0. And I hit graph, and because I've got a color graphing calculator, you can see that it drew it on the x-axis. And now I'm going to find where those two lines cross, known as the intersection. So there it is, number 5, intersect. And again, the TI, he goes first curve, enter, second curve, enter, graph. Guess who cares, enter. There's one of them. It's at 1. And I have to repeat the process, unfortunately. And this time, to find the other x-intercept, I need to move my cursor closer to the other x-intercept, or else it'll keep finding it. The same one over and over. First curve, enter, second curve, enter. Guess who cares, enter. Negative 4. Okay, and if you see down here on mine, it says 1e to the negative 12. That means 0. So there we go. We found our intercepts. Let's go write those down. So let's go. What's a new color here today? Brown. Okay, my x-intercepts were at, what did we say they were at? Negative 1, I believe, and 4. Now notice how I wrote those as a coordinate pair. You need to write it like that. Okay, it needs the 0. And the y-intercept was at negative 4. Now, the x-intercepts, we're going to graph it for today. But the y-intercept, I want you to recognize right there. That's the constant term. Because if you let x equal 0, that's what you're going to be left with. Okay, so there's some major parts of our graph. So we've got the vertex, we've got the minimum, we've got the axis of symmetry, we've got our intercepts. The only thing we need to do now is our domain and our range. So for domain, the graph never stops going to the left, it never stops going to the right, meaning it doesn't stop going to negative infinity or positive infinity. So we write that as the set of numbers, x such that x is an element of the reals. Okay, that will always be the case for our graphs of quadratics unless it's a real life application. For the range, well, this one stopped going down. So we'd say the set of numbers y such that y is greater than or equal to our minimum value. And our minimum was 6.25, comma, y is an element of the reals. Okay, so we're finding all of this information today by graphing. Let's try it one more time. So what I want you to do here is you're going to graph this function, and I want you to see if you can find all the parts. So hit pause on the video. I'll see you in a couple minutes. Okay, friends, let's see how you did. So if you graph this, it should look like that. And this time, do you notice it's a downwards facing parabola? Okay, we're going to talk about that in a moment. So there's what you should get, and you should see that I've got my line drawn across the x-axis to help me find my x-intercepts. Okay, so there's what the graph looks like. Let's go write down all of our information. So what we should have, our vertex of this was at 0, 9, if you found it correctly. That means my axis of symmetry is at x is equal to 0. That's the line that cuts my graph in half. This graph has a maximum because it's facing down. You could say at 9, or you could say when y is equal to 9. Okay, so again, the vertex gives us two really important pieces of information. Your x-intercepts would have been at 3, 0, negative 3, 0. Your y-intercept, I can read right here, it's my constant term. It's 0, 9. Again, you could have found that in your calculator just by hitting the trace button. And then our domain and our range. Okay, so our domain, again, any x value is acceptable in the equation. And looking at the graph, it never stops going to the left to negative infinity. It never stops going to the right to positive infinity. The range, though, will be the question that, or the part of the question that will change. So this graph, you say the set of numbers, that's what that brace says, y, such that all of our y values are less than or equal to that maximum. So again, when we find that vertex, it's really helping us find our range. Okay, there's all the important parts. Now, how did I know this graph would open down instead of opening up? Right here. See that negative right there? So out front here, it's called our lead coefficient. And if it's greater than 0, so if a is bigger than 0, our graph will open up. And if a is less than 0, guess what? Our graph is going to open down. As simple as that. So there it is, friends. There's your key components of a quadratic function. And like I just said, if a is greater than 0, the graph is going to open up. If a is less than 0, that graph is going to open down. And the c value, known as the constant, it tells us the y-intercept. So you should be able to tell me that information without graphing, and then everything else I want you to graph and find out. There it is, friends. See you next time.